Hello friends, we want to look at some solved examples. So example 1, factorize completely x cubed minus 7x minus 6 and hence find the zeros of f of x. So to begin with, we are going to use the trial and error method. So we'll start by assuming, let's say x is 1. So if x is 1 and f of 1 is 0, then we can say that x minus 1 is a factor. So let's test f of 1. We are going to have 1 cubed minus 7 times 1 minus 6. And this is going to give us 1 minus 7 minus 6. 1 minus 7 is negative 6, minus 6 is negative 12. So it means that f of 1 is not 0. So x minus 1 is not a factor. X minus 1 is not a factor. So what do we do? If x minus 1 is not a factor, we will move on to, let's say, x equals negative 1. So let's check x equals negative 1. So we also want to check if f of negative 1 will give us 0. So our function is f of x is equal to x cubed minus 7x minus 6. Let's remind ourselves. So f of negative 1, is going to give us negative 1 cubed minus 7 times negative 1 minus 6. Let's try to compute this. Negative 1 cubed will give us negative 1. Negative 7 times negative 1 will give us positive 7 minus 6. Negative 1 plus 7 will give us positive 6 minus 6. We get 0. Great. So this tells us that f of negative 1 is 0. And this tells us that x plus 1 is a factor. It is a factor of f of x. Now, if x plus 1 is a factor of f of x, and we divide f of x by x plus 1, we will get another factor. And we will get a quadratic factor. So our next stage is that we are going to use synthetic division to divide f of x, which is x cubed minus 7x minus 6, by x plus 1. Alright, so x plus 1 equals 0. We are going to have negative 1 out. Now, when we take a look at this function, the component of x squared is missing, but it will be 0. So in fact, we can write f of x as x cubed plus 0x squared minus 7x minus 6. And that is how we are going to write it for the long division. We're going to put down our coefficients 1, 0, before negative 7, before negative 6. We should not leave any components out. Of course, we drop our 1. Negative 1 times 1, negative 1. 0 minus 1, 0 plus negative 1, 0 minus 1, negative 1. Negative 1 times negative 1, positive 1. Negative 7 plus 1, negative 6. Negative 1 times negative 6, positive 6. Negative 6 plus 6 is 0. Of course, it is a factor, so the remainder should be 0. Now, with our highest power of x being 3 for f of x, and our highest power of x being 1 for the divisor, our quotient is going to have a highest power of what? 2. So we're going to write it as x squared minus x minus 6. And that is our second factor, or our quadratic factor. So to factorize completely, let us factorize this quadratic factor. X squared minus x minus 6. We look for two numbers, the sum of which will give us negative 1, the product giving us negative 6. We can deduce 2 and 3, 2 and negative 3. And so let's replace 2x squared plus 2x minus 3x minus 6. X out, x plus 2, minus 3 out, x plus 2. This is equal to x minus 3, x plus 2. So this is the complete factorization of the quadratic factor. So therefore, the complete factorization of f of x will be our initial x plus 1, our second x minus 3, and then the third x plus 2. That is complete factorization. Now the second part of the question said, hence, find the zeros. Simply equating f of x to 0. Now since we have factorized it completely, we are going to have x plus 1, x minus 3, x plus 2 all equal to 0. So if x plus 1 is equal to 0, what will x be? Negative 1. If x minus 3 is equal to 0, what will x be? Positive 3. And if x plus 2 is equal to 0, what will x be? Negative 2. So therefore, the zeros of f of x are x equals, let's start from the smallest number, negative 2, negative 1, and 3. Take your time and then solve it. You may try one or two examples of your own.